Hi, this is Nick from VireEngines.com. I'm just going to show you another video from a different angle of how to fit your pump impeller. This is a nice time to do it because I've got this Concourse Vire 7 in build, so all the parts look gleaming on this, and it makes it a little bit clearer. Haven't fitted the exhaust on at the moment, but it wouldn't make a lot of difference if you can get to the back or use a mirror. But you can see clearly what I'm doing here. So I'll just show you first. I've got all the parts and tools I need ready. So the most important thing here is probably the blanket under the engine to catch anything that you drop. Then I've got my original parts. Just losing a leg of this tripod, sorry. So we've got these gaskets, and these are a special thickness because if they're not an original part, it changes the gap between the two brass plates, and that means that the clearance for your impeller is wrong. If your gasket is too thin, it will jam the impeller and burn it out, and if it's too thick, you've made it yourself, what will happen is there'll be a clearance, and the water, instead of getting pumped around, it will just leak back around the edges of the impeller. Can't stress the importance of a quality OEM impeller. I actually have these manufactured myself, and that's because the batch I was getting from dealers till they went bust was faulty. They hadn't properly glued these brass hubs inside, and I insisted that they threw away all that stock and made them properly. So as far as I know, I'm the only place you can get these in the world which are reliable, and you don't want to change this very often. So original gaskets, original impeller, both available on VireEngines.com, and I've cleaned up the parts. I've used a Dremel to clean inside, clean the pipes out, and the gasket face. And similarly on this, you can see there's a little wear ring, but I've polished. There was a deeper wear ring. I've just polished that out with a sanding Dremel, and that's going to be nice where the pump sits. There's no deep ridges in there. Sometimes people ask to buy this part. It's never necessary. You can always polish this material out. Even if you made that half the thickness it is, it wouldn't be a problem. You could just add some washers on the bolts to compensate if you've made this thinner, but just polish that out until it's going to make a good seal with the back of the impeller on there. The other side, this concave side, it faces the engine, and the reason for that is that the lips on this outer seal may be slightly high. You don't want them touching, so they've done a recess on that side. So you know the recess side goes towards the engine. Finally, you'll see that you've got two big bumps and one relatively flat surface. The flat surface goes at the bottom, so it wouldn't fit it that way round. It would go that way round. Otherwise these three holes wouldn't line up very well. And obviously the same with the housing, even though the numbers end up upside down. This is a Vire 7, so it's got the outlet pipe going upwards. The Vire 12 will have it going horizontal usually. That doesn't really matter. So assembling with the gearbox in between, sorry, the gasket in between the two halves, and there's a sequence to this. So what you'll do is, first of all, we'll make sure that our Woodruff key is fitted in the shaft. Now these are again a special Vire part. They are stainless steel. How do you check if you've got a stainless one? I always put it on a magnet. I'll never put one of these in an engine without putting it on a magnet first, because if it's not stainless steel, which means it would stick to a magnet, if you put it in here in salt water, this will rust out within about 4 months, and the impeller won't be able to turn. You could overheat and seize the engine and destroy it. So for the sake of 10 seconds, just put this on a magnet. Make sure it's not able to stick to the magnet. You've got stainless steel. The way that you put this in, you've got your capture thing. I'll zoom in for you now. You'll see that there is a slot in the shaft ready for it. Incidentally, this shaft, all the engines I rebuild, I've got a stainless steel sheathed shaft, which is a £150 exchange on the site if you want it with the gears fitted, and that means it won't rot out. There was a design flaw when they originally did these engines, so that shaft corroded because there's an air hole they put in between the seals underneath. The shaft corroded, the seals failed, the water went in the gearbox and the clutch jammed, and sometimes it would stay in there long enough to rot the gear wheels and clutches beyond repair as well. So the solution is to fit a stainless steel shaft which drives this pump, and then the rust won't start to come on these seals. Also, these seals I've replaced during this gearbox rebuild, like all of my engines, has triple seals, not double seals, so there's a gap between the two circlips, and I put an extra seal facing the same direction as this one, and obviously the lips face outwards towards the pressure, which is correct. I say that because half the engines I get in which are ruined is because they put this seal in back to front, or they've tried to hook it out with a screwdriver and they put a new seal in but they've scratched the shaft, which makes it worse, not better. So don't bodge it. If you're going to have a reliable gearbox in salt water, you need a stainless steel shaft, you need to take the shaft out, upgrade with new seals, preferably triple seals, and stainless steel circlips as well. So the method to get this in, I would suggest use some long nose pliers, and I'll just get my spectacles so you can really see what you're doing. And you want to put this in so it gets it started, line it up, and you won't get it all the way in with this. You can feel that starting. Should be a nice firm fit. So if you can see, that is now proud, but here's my top tip. These are called pump pliers, okay, and they're beautiful at pressing it together. So you can put these between the two halves and it will squeeze it down evenly, like so. That's just ejected the grease, and you can get that nice and flat. It's pretty good. It's only about 0.5 millimeter proud, this key. Before you go any further, make sure that you can slide your impeller on and off. It should be loose or firm. That is absolutely perfect. Right, it's not going to get snagged up later. So before I put all the sticky gaskets in the way, I've checked that that Woodruff key is perfectly on. Okay. So now we have a sequence which is going to be base gasket, and then base plate, and then impeller, and then we're going to stick the second gasket to our housing cover, and then we are going to gasket glue that side, smear it, make sure you haven't got much inside, and then we're going to twist it on in a clockwise way. So here we go. So first job is to put sealant on the base. You can be fairly liberal with this because it's not going to go in the impeller cavity, but you don't want to get it anywhere near those seal lips, because the seal lips is what's keeping the water out. So our first gasket, we'll find the flat side, and the original gaskets have got that fairly easy to see, and then put that over the holes ready. Now we have our base. So I'm going to do is I'm going to put gasket glue on the engine side, and I like to smear it flat with my finger. It means it's nice and even. So that's ready, and that goes on. And you might find you can't get this on with the Woodruff key in. Usually there's enough gap somewhere. You see, I've made a mistake there. I didn't have the flat bit at the bottom. That's better. Right, now I'm just checking to see all my holes are still lined up. I can just feel that they are, and move the gasket as appropriately. Okay, good enough. Right, now we have the impeller. So that goes on. You can rotate this out of the way. That's now on. Then we stick the housing This is high Lamar. It's the only stuff I would recommend on a 7. A lot of the 7s have a banjo bolt under the cylinder, which is only about 2mm clearance when it's new. And so if you get a lump of silicon sealant, put the gasket on, flat side down. That's lovely. Then it will jam in that hole and stop your cooling. Engine overheats, piston will seize, and it's all over. Oh, I've messed this up. I should have put that on before. Apologies. It's all wrong. You've got to put this on before the impeller, because it sits under the impeller, of course. That was silly. Right. So that's the sticky side. Down. Stay there. Then our impeller. Then our impeller. Right. And now we've sealed the housing. The trick. Now you can either rotate this clockwise 90 degrees as you push it on to get all the ears bent ready to go, or if you've got access to the front of the engine, you could turn that. But I think that's a bad idea because the gasket will slip round. So you're going to end up here. So if you start off in this direction and spin it as you go, I'm not putting it on flat, I'm putting it on kinked, and then I'm going to rotate this round, pushing as I go until I meet at 90 degrees, and that is all together. And now finally I've got my housing fixing bolts, which I carefully pass through all 3. Now these are upgraded, though they're not hex bolts like the originals. These are stainless steel Allen bolts, and the reason that I supply these is because it's very fiddly with hex bolts. You need a socket set, and there's on this bottom 2 bolts you'll find the rubber coupling is in the way, and there's not enough room to get a socket set in here with the rubber in the way. But when you buy a set of these from me, you get a special Allen wrench which is L-shaped, but the short part of it has been shortened by me, so you can get it in that gap to tighten these up or loosen them, and that makes servicing a lot easier, and you've got less tools to drop in your bilges as well. So more reliable and less chance of losing tools. Now, engineer's rule is get all of the bits in and tighten evenly. Don't tighten one bolt. And this just helps locate the gasket as well. So start these off. During the refurbishing process for this engine, I checked all of the threads in the back of this gearbox. These happen to be perfect. Sometimes they're a bit rotten or have been badly repaired by people, and so in that situation what you want to do is buy a helicoil kit, which are about £15, and you can drill it out to a slightly larger diameter, tap it with this special tap, and that allows you to put this coil of stainless wire in, which then brings the thread back to the original metric thread that these bolts were designed to fit. And that means you don't have to drill out the brass housings or anything. Keeps it original. I find you need quite a long thread, so I put 2 in if I can get 2 in, not just 1. Gives it extra strength, because you don't want just one weak thread in an engine, which might be tight when it goes out, but you've got to think about the owner and him servicing it in future. So I'm now evenly tightening these bolts up. As you can see, I'm just using wrist tension. I'm not putting a socket set on these, which means I'm just taking the sealant down to the gasket level, and that's it. Job done. So we've now finished that, and apart from me forgetting that you have to put the gasket under the impeller before you put the housing on, that went quite well. So if you buy an impeller off of me, you also get a A4 tip sheet, which I've done, and it's actually 4 sides of paper reduced onto probably 2, and it gives you photographs and shows you this whole process and how to test it as well. So there you go, have a look. If you get an impeller from vireengines.com, you'll get the whole printed tip sheet as well to help you go along. Hope you enjoyed this video. Do leave me your feedback. Thanks.